So this is a brief overview of how to digitize video from the ME780 lab for the purposes of finding the vertical displacement versus time, as well as the horizontal velocity of the unsprung and sprung masses of the vehicle. So a useful freeware tool that's available online is this Tracker Video Analysis and Modeling tool. So you can download it for a variety of different OSs here. When you open the software after installing it, you simply import a video. I'm going to choose the unsprung mass location Haversine profile that's in phase. So that's a Haversine road profile, and the slow speed of the RC vehicle. This is an MP4 format. This is uploaded to the Learn web page. So when I click open here, it's going to import all of the frames of that particular MP4 video file. And then you're going to see the video that's been imported here. So as I previously mentioned, we intentionally fitted in a breadboard LED with a battery to the vehicle, and that's a red LED, just to have a large amount of contrast between the color that we are going to select and seed the software with and the background. And we've turned off the lights and reduced the exposure time quite a bit so that all we're seeing is the red LED. So if we just move this progress bar here in time, you can obviously see the red LED tracking across the screen. So the first thing that we're going to do is crop the video to the extremities of what we want to process. So I know from previous that around 335 frames is when it begins, and around 480 is when it ends. So I'll go to those 2 points there, and then it's about 338. Okay, so now that we have that done, we need to scale the image so that the software can actually extrapolate number of pixels and calculate the real distances. So this is somewhat of approximation. So what you're going to do here is, this is the calibrate tool. If you click the down arrow and then new, we're going to use the calibration points method. So that brings this crosshair up on the screen. So if you click in the middle, you can drag the crosshair to where the LED light is. That's just so we have a straight line across the screen. So now we're going to click new calibration points again. And if you shift select, you can see that the cursor has changed into a target from the cursor. So I'm going to shift select the left and right extremities of the frame. So I know from experience that this is about 0.95 meters. So now it's asking me to input the X and Y coordinates of each of those 2 points. So I'll just enter in 0 for the X for the left, 0 for the Y. Y2 is also 0, and then X2 is 0.95 meters. So these are standard units. So when I click enter, now the image is calibrated, and what we're going to do is track the motion of this LED now. So if we click create, point mass, these are just different elements that you can use to effectively digitize different features on the video itself. So I'll click point mass here, and it will populate or generate a new point mass called A. So if I right click here and then I click auto tracker, what this is allowing me to do now is to define all of the automated inputs, or all of the inputs to automatically track the position of this thing across the screen, this feature. So to create a new keyframe is the reference frame. We're going to shift and control click, so that changes the cursor to this different circular target, and we are going to select the feature that we want to track. So if we click there, you can see that the template is going to be this circular image here. So what it's effectively using is brightness and color gradients, and a unique pattern of these brightness and color gradients over the whole image to track how this is moving. So we're going to leave the evolution rate and the auto mark as standard. So all we need to do now is click search, and you're going to see the software automatically calculating calculating and tracking the motion of this particle. So I'm just going to change the y-axis here to be the vertical displacement. I'm going to change this plot to be a plot, and I'll change this to the x component of velocity here. And once they repopulate, you're going to see obviously the live profile here. So what this is showing is that versus time here, and once again this is a slow motion video, so 4.5 seconds approximately in slow motion time is 1/3 of that in real time. That's how long it would have taken for the RC car to traverse the screen. But initially there's a few frames here where the object isn't moving. You can see the velocity is 0 and the y coordinate is almost 0 here. And then it starts to move, and you can see definitely the sinusoidal profile that it takes on. So every image of the videos is approximately the same scaling. So from the full extremity of the left to the full extremity of the right gives you approximately a 25 millimeter tall ramp, which when measured in reality, that is what's happening. So the sinusoidal amplitude here is 25 millimeters. You can see y in meters, and then there's a scaling of 10 to the -2. So this is almost exactly 25 millimeters. And you can scale this when you extract the data from the software. The important thing is to get the waveform here. Okay, so this is once again 2 Havre sines, and then the velocity. So the velocity starts at 0, and then when the vehicle starts moving, the velocity steadily increases at a pretty much constant acceleration rate up into about 0.3 meters per second. So what we can do is either of these plots we can turn into a table, and we can quite easily get time x and y, and we can just highlight all the data here. You can go to the bottom, and this will be for every frame that we've selected within the cropping extremities that we've set here. If we right click, we can go copy selected cells, full precision or as formatted. We can say as formatted here. So we can copy, and then we can simply bring up Excel, and we can obviously paste that data into Excel. And now you have the raw data that was digitized from this tracker software here. So similarly, you can complete this for all of the videos that you would like to use for your calibration cases. It doesn't have to be all of them, whichever ones you select. If you're not getting good waveforms here, especially in the shape, because you can rescale this once you bring it into Excel, try reselecting your seed here for the reference frame, and or rescaling the axes, the calibration axes. Do make sure that you're selecting the right component to visualize here. So this is the Y position, which is what we wanted here, and this one was the X velocity, which is the velocity across the screen. So that's important. As in conclusion, that was a brief overview of how to digitize the video that was provided and collected in the experimental part of the ME780 lecture.